Parallel arrays are two or more arrays that contain related data. If I was going to be specific, I would word it like this. In fact, I'll put it in the notes. But a parallel array, or parallel arrays, why not I just put it in the notes? We know we're going to upload the notes and we're not going to upload the PowerPoint. So, parallel arrays, two or more arrays of the same length, where the, and that's misspelled length, where the elements are related by index number. So for example, you could have a first name array. Fname is equal to, and I'm not going to do the syntax all correctly right, you know, Barack, comma, Donald, comma, Bill. 3 presidents. And then we have some last names. And his last name is Obama. Donald's last name is Trump. And Bill's last name is Clinton. And Bush is annoyed that I didn't use him in the example. All right, so there we go. These are 2 arrays. Yes, sir.
We've been over parallel arrays.
Good. Very good. Then why did it pop up on that slide? Have we had a homework assignment over parallel arrays? Something's nagging me about parallel arrays. Is that a yes or a no?
We did an in-class thing about it with
The days
store
of,
items. Prices,
okay,
color.
okay. That would be why it was nagging at me. I didn't make y'all do any homework over them. And we could list as many of these as we wanted to. And then if we were going to print them out, we would iterate through the list. I do want to go ahead and actually do this. But we'll make it a small example since we've already covered it. I didn't mean to choose console app. All right. The usual. Bless you. All right, so I'm going to declare those 3 arrays. String FN for first name, angle brace, end angle brace is equal to, and then just put in 3 names. Joe, comma, Bob, comma, Sue. And then another array, string ln, end quote, is equal to, angle brace, some last names, Roberts, Smith, and Long. Now let's find out the length of these arrays, because we need to know the length in order to process them, right? So int size, not going to be a constant, but I'm putting it in all caps anyways, is equal to, and how do we get the length of an array? We get the size of the array, into parentheses, divided by the size of the first element in the array.
Professor,
Yes, sir.
can we slow it down just enough?
Sure.
Thank you.
Now what we would probably want to do if we were going to go into a big example of this is come up with another array that held some more information about them. favorite food or something like that. And we could write a loop that would ask, you know, fill in this person's favorite food. And then we would have 3 arrays all linked up by their index numbers, right? So Joe Roberts likes food, subscript 0, which might be ice cream. Bob Smith likes food, subscript 1, sushi. Sue Wong might like, you know, food, subscript 2, McDonald's French fries, whatever, like that. And so when we would iterate it through it, we would use a single iterator, a while or a for, to print all that information out, or to ask for input. Let's just print them out. So for int I is equal to 0, I is less than caps size, I is less than size, I plus plus, and let's just print out the first name followed by a space followed by the last name. So it'll be cout fn subscript I ln subscript I. So cout arrow arrow first name subscript I arrow arrow double quote space double quote arrow arrow last name subscript I arrow arrow ENDL. So when we run it, it should print out Joe Roberts, Bob Smith, and Sue Wong. So I'm not going to actually do it, but I'm going to declare one more array of that size that we could then fill in with foods. So after int size, I'm going to do string food angle brace size, except size needs to be in caps. And it says that the expression must have a constant value. So that's telling me that I should hardwire the size as a const. Is it as easy as doing this? It surely can't be. Well, what do you know? All right, okay. So what did I do to fix it? I just added the keyword const to that line. Puzzles me you can get away with doing that because it can't. Oh, well, I guess it can. It can calculate this at compilation time, right? Because it knows how long this array is. And it knows the size of a string. So it can go ahead and do this calculation and create a constant with that. That's interesting to me, right? That actually worked. So does anybody do syntax errors? Everybody calls. And the word const.
Oh,
C-O-N-S-T there.
okay.
Okay. Maybe we'll go back and do the filling in the foods with an input statement. But for now, I want to keep lecturing. Go on ahead past this point. The arrays can be of different types. Right now, they're all strings, but I could have done an age array, which would be an array of ints, right? Here's their example. We're going to make an array called average, an array called ID, an array called grade. And we want 5 elements in each array. And so we're going to have 5 student IDs. Each one has an average, and each one has a grade. And then later on, after all that stuff gets filled out, we could print it with a for loop, just like we did here. I is equal to 0, I is less than size. Print out student ID at that element, average subscript I, grade subscript I. And so this is showing that we've got 2 arrays here. They're both of length 5, so they can be parallel arrays. We have an hours array, and we have a pay rate array. And they typed in that Element 0 of ours is 10, the next one is 15, the next one is 20, the next one's 40, and the next one's 40. And then their pay rates. Pay rate subscript 0 is 975, and then 862, and then 1050, and so on. So then when they wanted to print them out, they would just multiply hours subscript 0 by pay rate subscript 0. And then hours subscript 1 times pay rate subscript 1. Now what they really do, they wrote a loop to do it, right? You wouldn't just hard code those multiplications in there. Arrays as function arguments. We've already done this. We can pass in arrays as parameters to a function, as arguments to a function. Show scores tests. Just use the array name. To define a function that takes the array, you use the angle braces as your data type, right? Int tests, like that. Now this is not showing putting the size, passing the size in, which is what we wound up doing. I'd be interested to do that. When passing an array to the function, it is very common to pass the array size in so the function knows how many elements to process. This is also good for partially filled arrays, right? Just because we've allocated 10,000 pieces of information, maybe only the first 500 have valid data. We could tell the function that the array size was 500. Doesn't matter that there's an extra, 9,500 that aren't being used. So show scores tests subscript array size. That means that we're passing that array in and we want it to have some kind of loop that's going to count from 0 up to but not including array size. So the header for it, remember you can leave the variable names off, the parameter names off when you declare a header. So here's how they declare their function. Show scores, int tests array, int size. But then when they define their prototype, they just left the variable names off. And you've heard me say it before, but I don't see any good reason to leave the names off. I think that that's being too clever by half, because it's very useful to go and being able to look at the header of a function and see exactly what it's supposed to be doing. And if I just see int, square brace int, I don't know what kind of data I'm supposed to be passing to it. Oh, I'm going to be sending an array of test scores, and this is supposed to be how many there are. I can easily understand how I'm going to use that function looking at that. But just looking at the prototype, if it didn't have those parameter names, I wouldn't know. So here they have a function called show values. They don't have the function, but there's the prototype for it. Show values. It accepts an integer array and it accepts an int, which is going to be the size. So they declared their array, they declared their size, and then they called show values, and they passed in the array and they passed in the size. And we're pretty sure that we know what show values is going to look like. It's going to be some kind of loop. Modifying arrays and functions. Now, regarding all of that lecture about whether you can change variables or not, remember that when we were talking about references and pointers and stuff like that, you can change the contents of arrays. Let me show you what I mean. In our code, let's go and add a function up here called, I don't know, void change it. And it's going to take I'm going to just call it ARRAY subscript in subscript. Now I should pass in the size and make sure that I'm not writing past the size, but really all we're going to do is we're going to set the first element in that array equal to something totally different, Zeke. So if I call change it down here and I pass in the first name array, and then I call change it down here with the last name array and run it, it's going to pretend that somebody's name is Zeke, as well as Bob Smith and Sue Wong. So we have Zeke, Bob Smith, and Sue Wong. So you can change the contents of it. Well, how does that work? You said that you couldn't change the values. Well, what is being passed into here is a value, but it's a value of an address. And it can use that address to change the elements of the array. In effect, this is a pointer. We haven't talked about pointers for a little while, but in effect, this is a pointer. And it's using this pointer to change the elements of the. But that does not mean you can change array itself to point to a new array. And I'll show you what I mean. And this code was not going to work. But what if we did this? I want a brand new array, please. Array is equal to, and then let's give it some new pieces of data. Luke, Tim, Sam. Too many initializer values. I'm not going to take the time to fix this. Just trust me that if we try to create a new array, oh heck, let's get it to work, even though it's not going to work. I hate spending a lot of time to make something work that's not going to work, but okay, fine. String new A, standing for new array. And then let's set array equal to new array, like that. When we get back, we might think that the array has been reset to this new array, right? Because, hey, look what I did. I changed array to point to an entirely new value. But it's not going to do it. It still says Bob Smith and Sue Watt. So it can use this array to change the elements of the array, but you can't create a brand new array. Pass it back. And the same is true of objects and classes, data structures. You could pass in a data structure and you would be able to change the elements of the data structure, like when we had a patient class, right, and it had a first name and a last name. We could have a function that would let you change the first name and the last name of somebody, but it couldn't create a brand new patient object and pass it back that way. If you want to pass it back that way, there you've got several choices. One is you could issue a return statement to return it. Another is you could pass it in as a reference with an ampersand. If we change this to pass it in by reference with an ampersand, then by the time it got back here, our array really would now say Luke, Tim, and Sam. I think I'll do that just for fun. And then I'm going to wind up commenting the things out that I really don't want us to be doing. So if I put an ampersand there, that's saying that's not a copy of the array. Ooh, it's not even letting me do it. What is the error? An array of references is not allowed. Okay, forget it. So well. We could do it as a pointer. Not going to bother. Just accept that if you pass in an array, or you pass in an object or a structure, you can change the elements of the array, or the object or the structure, but you can't reassign it inside that function and have that take effect down here. Because we are still doing pass by value. The value that it's getting is the address to the array. It can use the address of the array to change the data in it. Just like if I hand you a map to my house, you can use that map to go to my house and break my windows, right? It uses the address in order to change the elements. But it can't change it. Just because I did that doesn't mean that you can, buy me a new house. That's a really stupid one. Forget I said that. I'm embarrassed by that. Okay, so I'm going to get rid of these two things because they didn't work. So you need to exercise caution that the array is not inadvertently changed by the function. Because we just saw that it can, right? This function just overwrote the first element in both of our arrays so that it said Zeke Bob Sue and Zeke Smith Juan. If that wasn't our goal, that would be a real problem. So when you pass an array in, you have to be real careful to not let it make changes to it if that's not your goal. What happens if we put the word const there? If you put the word constant in a parameter, it tells the compiler to look to make sure that that value is not being changed.
You want us to do that?
And I was changing it, right? I may wind up deleting, I'm not sure. But by telling myself, or telling the compiler, this array shouldn't be changed, if I put in the word const there, then anywhere that we try to change it is going to be a syntax error, a compilation error. So that's a way that you can fix the vulnerability of arrays. If you care. What that does is it stops the compiler from doing it. It doesn't magically make that array invulnerable to like buffer overrides or something like that. If there's something wrong with your program, just because you mark a variable as a constant doesn't mean that it's ultra safe. It could still get overwritten by a buffer overrun. We've talked about buffer overruns. Buffer overruns, array overruns are when something is writing past the end of an array or using an improperly set pointer. I guess I'm going to remove that. But I'll put a comment. If I wanted this code to prevent changing the elements of array, I would use the const keyword. Void, change it, const string array. I'm going to delete this entirely. We've kind of illustrated the point. And to me, if I was looking at this in the far future, I wouldn't understand why I was doing that. I'm going to delete those two lines entirely. So if you're writing functions that take an array as an argument, go ahead and think about just making it a constant, just as a habit. Because then if you wind up needing to make changes to the array, you know you need to go and modify that parameter, but at least you're not doing it accidentally. And by the way, the word const can be used in other contexts as well. For example, say I had a function that looked like this. Void foo parentheses int I. And I don't even know what it's going to do. But if I did not want it to allow to change I could stick the word const there. And then if my code tried to reassign I like that, it would flag it as an error. Now, have I been doing that? No, but I could. You could make all your input parameters marked as const. In general, we haven't been changing the values of the parameters anyways. Why? Because the changes would not trickle back to the calling code, right? Unless there were references or pointers. So maybe I should have been showing you making them const, but we haven't worried about it. We've assumed that we knew that if we were going to change those parameters, if we were going to change the value of it, it wouldn't take place. Two-dimensional arrays. Now these are more fun. What is a two-dimensional array? Well, right now we just have lists. Right? You pop open Excel and you have rows and columns. You have what's known as a grid or a matrix. Right? And you can store numbers anywhere in it. Remember the old game of Battleship, you know, where you were trying to find the opponent's battleship and you'd say, A3, guy would go, you sunk my battleship, right? You know, that was a grid. That was a two-dimensional array. Like a table in a spreadsheet. You have to have two size declarators in your definition. Both the number of rows and the number of columns. So this line here would create an array that is, 4 rows of 3 columns. We could do something like that. So let's go down and above our pause, const int rows equals 4, comma, calls equals 3. Now let's make our array. Int grid square brace rows in square brace calls in square brace. And let's fill them all with zeros, right? Our array is just going to be chock full of zeros. You use a nested loop to print this out. Do you remember the rectangle printing assignment where we used a nested for loop to print out the asterisks that made our rectangle?
Let's act like we don't know.
Pardon me?
It says let's act like we don't remember.
Right, right. So we're going to use a nested loop, but instead of printing out asterisks, we're going to be printing out the value of our array. So let's do that. For int, how about we use R for row? For int r is equal to 0, r is less than caps rows, end cap, or semicolon, r plus plus, now for parentheses, int c for column is equal to 0, c is less than calls, all caps, c plus plus, C out, arrow, arrow, grid, square bracket, R, end square, square bracket, C, end brace, and I didn't put braces around that C out. I think I'm going to do it because we're used to seeing them. Right. So there we go. I just added that square brace. Excuse me, that curly and that curly. And after that one, I'm going to C out just a slash in for an ENDL. When we run this, it's going to print out a little box, all of zeros. 4 rows of 3 columns of zeros. We won't be able to visualize real easily what the data is yet because it's just all zeros, right? It's not informative. So what I'm going to do to make it look a little bit more informative is we're going to give ourselves some better initializing data. I'm going to comment that one out, but I'm going to type it in again, pretty much. So you may as well copy that. But we're not going to initialize it to values of 0. The initialization statement is going to be a little bit nasty looking. Okay, so here's what I want my first row to be. I want my first row to be 1, 2, 3. End curly brace, comma. Here's what I want my second row to have in it. 4, 5, 6. End square brace, excuse me, end curly, comma. 7, 8, 9, end curly brace, comma, and then our last row of data. I'm just going to make it 0, 0, 0, with no comma. Looking at this, you get the idea of what a two-dimensional array really is. It's an array of arrays, right? Grid is an array of 4 arrays, right? It's got a large initializer, which contains 4 arrays, and then each one of those subarrays has 3 elements. So if you have a 3 by 4 array, how many elements are in there? 3 times 4, 12 elements. Now if I ran it, hopefully it would print out, you know, those numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0. I want to make sure that that does work for everybody who's typing it in. Why did I put a slash in there? If I commented that out, what's it going to do? Huh? Yeah, it's just going to print all the numbers like that. So why did we put the slash in there and not here? What would happen if we had done that here? Yep. It would, whoops, what am I doing? Spacing out. It would just be one long stream of numbers because every time it printed a single element, it would go to the next line. That's not what I want. Like that? Nope. So really what I want is just how I had it. I'm going to delete that line and uncomment that one. I want it to print out an entire row. Then go to the next line. Pardon me? Scroll that way? Is that far enough or further? Okay. So remember that idea behind a nested loop is that you have an outer loop and the inner loop. The inner loop runs and completes
completely before the outer loop ever iterates again. So what we're doing is we have a row number of 0, and then we count columns. 0, 1, 2, 3. Once that's done, then it comes back up here, and row gets incremented by 1. So now I'm using row number 1, columns 1, 2, 3. And then it comes back up here. Increments are again. Row number 2, columns 1, 2, 3. So this gets repeated over and over and over. How many times do we print out? Well, 3, 6, 9, 12. So on the exam, I'm pretty sure I'll ask you a question. How many elements are in this array, this two-dimensional array? You know, and if that says 10 and that says 5, the answer is not 15. You don't add them, right? Because it'd be 10 rows of 5 columns, and 10 times 5 is, yeah, 50. Exactly.
So if I wanted to change this element to a 1 before I printed it out, grid subscript equals 1. What numbers should I fill in into my square braces there? Obviously, they're syntax errors because I haven't filled in my subscripts yet. Well, what row is it on? I'm wanting to change that one. Remember zero-based indexing. So this is row 0. That's row 1. That's row 2. That makes this row 3. So I'm going to put a 3 there. So what's this number? Going horizontally, what element is that? Don't say 2. Did I hear it?
1.
It's 1, right? Because that's element 0 and that's element 1. Now when I printed it, we'd find out that the bottom row has a 1 in it. Like that. I wish I/O manipulators were easy to use, because what would be kind of cool would be to make an array that was like a table of multiplication values or something like that, right? You know, 1 times 9 that way, 1 times 9 times that way, and then you can see that 9 times 9 was 81. But to get that to work, we'd have to be using I/O manipulators in the set width, and I don't feel like looking up to how to do that. So onward and upward. The first declarator is the number of rows. The second declarator is the number of columns. Here's their example, better than mine. We have 3 divisions with 4 quarters. So if we were going to try to allocate an array for this, we might decide, well, it's going to be a 3 by 4 or a 4 by 3 array. We just have to figure out which one makes more sense to us. I would say that since there are done 3 divisions, we'd want 3 rows, and the columns could be quarters, right? That's how we'd set it up on a spreadsheet, probably. Divisions down the side, quarters, or vice versa, right? You would pick, and as long as you were consistent in how you used it, it would make sense. Alrighty. There is some weirdness you can do with arrays. Let me show you what I mean with two-dimensional arrays. I'm going to create a really jerkazoid array. Int jerky. 2 pairs of square braces equals curly brace, and then another curly brace, 1 comma 2 comma 3 comma 4 comma 5, end curly brace, comma 4 comma 5 comma 6. An array may not have elements of this type. Alright. Well, good. I'm glad it's not allowing me to do that. This is what's known as a jagged array. And apparently it's not a problem in this language. Thankfully, in Python and in Java, you can get away with that. Where I was going with this is that we have something with 2 rows, but it's got differing number of columns in it, right? This first one has 5 columns, and the next one has only 3. Didn't work, so I'm going to nuke it. Now, the difference between this language and those other languages is that in C++, an array is just a pure primitive data type, whereas in those languages, it's a class. And so classes could support more sophisticated functions. In C++, we are coming to the conclusion that the rows and the columns are fixed and they can't vary inside the array. You can't have a row that consists of 3 columns here and 5 columns in the other. Now, I hope that's true and that I don't find another slide that says it, tries to prove the opposite. So a 2-dimensional array is initialized row by row. We have 2 rows, 2 columns. Here's how they initialize it. They did it in 2 lines where we were kind of spreading it out a little bit more. Same idea. You can omit the inner braces. Some initial values in a row array elements without initial values will be set to 0 or null. Do I believe that? Do I even understand what that's saying? I'm going to redeclare my jerky array. I'm going to make it a 2 by 2 array. And then I'm just going to fill it with the values 1, 2, 3, 4. And that actually worked. So the first row would be the numbers 1 and 2. The second row would be the numbers 3 and 4. If we didn't give it enough values, they would just be initialized to 0, like we've seen in the other ones. That means that up here, we didn't need to make it as sophisticated looking as we did here. I'm going to make this change, but I don't necessarily want you to. I could have done this. Like I said, don't make this change. I think the data is much easier to read the way we had it. But this would have worked as well. This would not have worked in other programming languages, but C++ is happy to accept this. Right. There we go. It looks like a 1-dimensional array. But we told it that it was a 2-dimensional array, and so the compiler is going ahead and will divvy it up so that we have the right number of rows and the right number of columns. I am going to undo that because I think, to me, that this is far clearer when we actually have them broken up like that, where we can see each row of data, rather than just kind of hoping that we can count it. Well, the first 2, like what if this was going to be a 3 by 2 array? If I change that to a 3, my jerky 2 array says 3, 2, and then I added 2 more values here, 5 and 6. How's it going to be? Is this our first row, and this our second row, and this our third row? I believe that to be the case. Let's write another for loop for printing those out. But I didn't put 3 and 2 inside a constant, so I'm just going to hard code the array. For parentheses int r is equal to 0, r is less than 3, r plus plus. And then inside there, for parentheses int c is equal to 0, c is less than 2. Why 2? Because there's 2 columns in every row. C++. Let's C out jerky subscript C, subscript R in subscript C in subscript, followed by a space, just to widen it out. And then after that for loop, let's write out a blank line. C out arrow arrow ENDL, or quote \n. And there we go. We saw that our data 1, 2, 3, 4, 5, 6 has been divvied up like this. 1, 2, 3, 4, 5, 6. If we made it a 2 by 3 array instead, then it would print it out differently. Just for fun, I'm curious about what's going to happen here. I'm going to change that to a 2 or 3. I wouldn't don't even make this change because I'm trying to break the program. Is it going to be happy enough doing that? Why should it be a concern? Because we only have 2 rows, but we're going to be trying to print out 3 rows. And it sure did mess up. Okay, so anyways, that was just a curiosity for me. As always, you want to keep track of your, make sure, we should have defined these as constants and used those, right? Num rows, number columns, or something like we did up here. That's the correct way to do it, rather than hard code numbers. I guess I had that originally as 3-2. Is that what I had originally, Jerky, 3-2?
Yes.
Okay, thank you. So a 2-dimensional array is a parameter. Use array names as an argument in a function call. I'm skipping that. Why would you do that? That's horrible. You shouldn't have to do that. This is saying that we have to okay, that's obnoxious. What if we were to put this code right here inside of a function so that we could print out a 2-dimensional array of whatever size we wanted to at any time? I'm going to try to write one that'll do that without using that weird little syntax that they had there. So void print 2D parentheses, and it's going to take an array. I'm just going to call it array. Array subscript subscript, and then it's going to have 2 values, int rows comma int calls, and I'm seeing an error there. Okay, so to pass in an array as a parameter, if it's a 2-dimensional array, you have to do some strange hackery to the syntax. And I'm calling it strange hackery because I've just never have. Apparently I skipped over this slide for the past 5 years that I've taught it. It's wanting us to fill in a number there. I don't want to fill in that number there because I want this array to work on any size of array, not just one with a fixed size of columns. And we've already seen that we can't create an array like that using a reference. Alrighty. Okay, well that did not work. I'm going to delete all this. I won't ask you any questions about passing in 2-dimensional arrays as an argument to a function.
Like, you mean you won't do that on a test?
Right, I'm not going to do that on the exam or any homework like that. I'm not assigning any homework for the rest of the semester anyways. But here's what it is saying, is that if we wanted to write a show array function that took a 2-dimensional array, the size of calls would already have to have been declared as a global variable, as a global constant. There's got to be another way of doing that, but I'm not going to take the time to Google it up. That's just the most perverse thing I've seen today, but the day ain't over yet. So summing all the elements in a 2-dimensional array. Well, we know how to sum all the elements in a 1-dimensional array. We have this little jerky array here. We could write a loop that would add up, that would calculate the total of that array. Let's do that. You have to have an accumulator variable. I'm going to call it sum. Int sum is equal to 0. And then it's going to do all this, but it's not going to print anything else. But otherwise, it's going to be the same code. I'm going to save time, copy those lines of code right there, paste it and delete the couts. And here I'm going to put sum plus equals jerky, because that's my array name, subscript R, subscript C. See, that looked just like it did when we were doing a 1-dimensional array, except, you know, we have the inner loop to take care of as well. And if we printed out the sum, we could do that. See out. Sum is, in quote, arrow, arrow, sum, arrow, arrow, ENDL. All right, and the sum is 21. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 11 is 21. Yep, so that worked. What if we were going to sum that top array? We'd use a two-dimensional loop, except we'd instead of using 3 and 2 as our limits, we'd use our max rows in all caps and calls like that. We may as well do that. Let's come up here, and after we printed out our grid, let's calculate the sum. And we've already got a variable called sum declared lower, so I'm going to call this one total. And total is equal to 0. And it's going to be a for loop just like these. I could copy and paste them if I wanted to. For int r is equal to 0, r is less than, all caps, rows, semicolon, r plus plus. I'm leaving off curly braces this time just to be a rebel. For parentheses int c is equal to 0, semicolon, c plus plus, oops, c is less than calls, semicolon, c plus plus, end parentheses, total plus equals, and this array was called grid, so grid subscript r in subscript, subscript c in subscript. And we've calculated the total of that array with those 4 lines of code. Well, we sure haven't been filling in very many notes here.
Can you go back to
I sure will. Two-dimensional array, use a nested loop to print out as a grid, and use a nested loop to calculate the sum total. Like that. All right, so while the recording was paused, I scrolled up and down. Here's the entire chunk of code if you need to see it. Pause as necessary. That's where we printed out our foods. Then this is the code that dealt with our grids array. We printed out the grid, and then we calculated the sum. Here's where we calculated the total. We never printed out the sum. We never printed it, but we did calculate it. And then we had our jerky array. That's where we printed it. And that's where we calculated the sum. And if I've been trying to condense the code so that we could put it as much on the same screen as possible, I could be deleting all the curly braces. Like that. You don't have to do that. I couldn't do it there though. Why? Because I had actually 2 statements in this block, not just one. So that would have been a mistake. Summing the columns of a two-dimensional array, we're going to leave that for next time. In fact, this is a good place to go ahead and stop. Is there going to be a lot of questions about a two-dimensional array on the exam, considering that we didn't hit it until the last day of the class, or second to last day of the class? Not really. I may ask you to tell me how many elements there would be in a 5x3 array, something like that, right? I could conceivably ask you to write code that would print it out, seeing as that we have examples of it in the notes, but probably not going to put too much. I'll have made that decision by the time we talk Thursday. two-dimensional arrays are not the big thing in my mind, but we've been talking about arrays a lot in this class as we got towards the end of the semester. So arrays in itself are an important topic, but one-dimensional arrays are where we're at.
So Thursday, are we going to review?
Yep, that's what we're doing Thursday. All right, so let's make a Dropbox for that. See, I forgot to put a name for you, and now I've forgotten what it was. Two-dimensional arrays. All right, even though I don't think we have any more homework assignments coming, I mean, I know we don't. You know, today, not sure why I made something due today. I always set it like for Monday or Wednesday, but anyways. Yeah, this is the last week. Homework assignment due this Thursday, but if you haven't finished homework, keep working on it, right? I'll take them through the end of next week. So just keep plugging away on your homework. If you know, some people like are missing half their homework assignments, and that'll kill your grade, as you probably noticed if you refreshed your grade page. So just keep working on homework. I can take them through next week as well. Are there any questions? Nope. All righty. See y'all Thursday.